Okay, so for this lesson, this will be our last lesson on graphing linear equations and everything about graphs for linear equations. All of the previous lessons you can find on the Virtual Learning website. There are previous recordings if you look at the timetables from the first 2 weeks. So our lesson objectives for today are, objective 1, recall the definition and properties of the slope of a line. Second objective, define the slope-intercept form. And our third objective is to determine the slope using the coefficient of the x once written in slope-intercept form. So what is the slope-intercept form for those of you that weren't here for the beginning lessons? The slope-intercept form is the same formula, y equals mx plus b. And this particular form makes it easy for us to find the slope because we know that the slope is represented by the letter m and the intercept is represented by the letter b. And this particular intercept would be the y-intercept. So once again, with this particular form, m represents the slope, b represents the y-intercept, and the y-intercept is basically when you graph the line, it's where the line will cut or interrupt or intercept, if you will, the y-axis. So whatever point is at the y-axis, where the line cuts that y-axis, that would be the value of your y-intercept. And then x and y would be whichever points are given in the coordinates. So once again, the role of m is the slope. It tells you how steep a line is. And the role of the b, which is the y-intercept, is the point where the graph cuts the line, it's the point where the graph of the line, cuts the y-intercept. So if you remember when we were plotting points and when we were drawing lines parallel to axis, with the ordered pair or the coordinate for the y-intercept, your points will always look like something where your x value is 0 and your y value will be the b from the formula. So the point of your y-intercept will always, your x value will always be 0 and your y value will always be the b value from the formula. Let's continue. So now, when working with the slope-intercept form, it is quite simple and it is used more often than the other forms. And remember, the first form was when we used the 2-point formula, when you're given 2 points to find the slope, which was, the formula was m equals y2 take away y1 divided by x2 take away x1. That was our first way we learned to find the slope. The second way we learned to find the slope was rise over run, and now the slope-intercept form is our third way, which is the simplest way. So now let's look at an example here. We have y equals 3 divided by 4x plus 3. So when you are given an example as such and you're asked to find the slope, first, you have to make sure that your equation is in the form or something that looks like y equals mx plus c. And in this case, our equation is in the form y equals mx plus b, and it's quite easy to identify the different parts. So from this, we can see that 3 over 4 is the slope, because the slope will be whichever value that is the coefficient of my x. And to take it a step further, 3 would be the point, or 0, 3 would be the coordinate where the line crosses the y-axis. So if you graph this line, when you draw the line, this line will cut the y-axis at 3, and that point would be 0, 3. But today's lesson, we're only really focusing on the slope. And so the slope would be whatever coefficient is on x. Any questions so far? Okay, no questions. So let's move on to some more examples. I give you another second for those of you that are writing this down. Okay, let's move on to some more examples. So once again, using this method, this is the easiest method to determine the slope of a line. And so the slope will always be an integer or a fraction, as stated earlier, attached to the x variable or the coefficient of x, which is basically the number that is directly in front of x. So we have another example at the bottom of the screen. Determine the slope for the line y equals 3x, take away 4. And if we look here, this particular equation is already in the form y equals mx plus b, because we can clearly identify m, which is 3, and we can clearly identify the b value, which is -4. And so therefore our slope is 3, because 3 is the coefficient on x. Any questions in an answer section? Okay, let's look at some more examples. As stated, this one is really the easiest way, so most of you seem to get it already. So now let's look at some more examples. Now, here we have another example. However, this example looks quite a bit different from the first two examples that we looked at. This is in the slope-intercept form already, but it's not quite clear for some people to actually see the m and the b parts. So what I like to do is write out the equation or the formula for the slope-intercept form, which is y equals mx plus b. And so we're going to manipulate this equation to make it look like our formula. And so for those of you that do know, when you have a fraction and your numerator has more parts than the denominator, basically what this is saying is 4x take away 10 all divided by 5. So everything in the numerator must be divided by 5. So we can break this down and make it look something like this. So these two equations are exactly the same thing. All I did was share the denominator 5 to make it look more like the slope-intercept form. So all I did was break it apart, and so now we have y equals 4x divided by 5, take away 10 divided by 5. And so we can simplify this a little, and we can get 4 divided by 5, leave it as a fraction. X, take away 10 divided by 5 is 2. So now this part right here looks a little bit more like the slope-intercept form, and we can clearly identify our slope here, which is 4/5, because that's the coefficient on the x. So as stated earlier, yes, our slope can be a fraction, and you would have seen that with the first two ways we use to find the slope. And so that is all to this example. Was the part where we split the denominator and simplified, was that simple and clear enough? You can send a Okay, awesome. So let's just look at another example for clarity. So now we have an equation y equals 12, take away 3x, all divided by 2. So once again, if you have something like this, where the numerator has more parts than the denominator, that basically means that you just share the denominator amongst the parts in the numerator. So we want to break this up and make it look a little bit more like our y equals mx plus b. So we will have 12 divided by 2, take away 3 divided by 2x. And then, as you can see, we can simplify our 12 divided by 2, and so that becomes 6. Now, some people may be able to identify the slope from this particular equation here, from our y equals 6, take away 3 divided by 2x. And then you may have some people who would be like, well, this don't look like our formula at the top here. So if you want to take it a step further, all you have to do is just rearrange that right side of the equation to make it look more like y equals mx plus b. And so if we rearrange, we would get something that looks like this. So this sign in front of the 3 divided by 2x will go with it. And so we just basically shift it over, and our 6 here is positive. So I'm just going to put that behind our negative 3 divided by 2x. So now we have something that looks more like our formula here at the top. And so now we can identify our slope, which is negative 3 divided by 2. And so that is basically, that's all to it. Any questions so far? Okay, I'm going to leave it up for another minute for those of you that are writing. Okay, I see a question. Someone's asking what B is called. B is called our y-intercept. Okay, I see another question. Will the equation be solved? In this case, no, you don't have to solve the equation. And really and truly, we can't solve this equation because we have two unknowns, which is y and x. But the solution for this equation would be when you are given points or coordinates for this particular equation for this graph, the x and y values from your points will be the solutions for this equation. But no, you don't have to solve the equation. Yes, you will be able to get the notes. I will talk about that later on. I'm also seeing another question. Someone asked if you had to divide the first two numbers. I am assuming that you're meaning the fractions that are on the x, the coefficient of the x. To avoid decimals, for the slope particularly, we leave it as a fraction or as an integer, no decimals. But for the y-intercept part of it, if it can simplify, if your fraction can simplify to an integer, then you can do so. But if it will simplify and you will end up with a decimal, it's better to leave it as a fraction. Okay, let's move on. Let's do a few more examples and then we'll basically be done for this particular lesson. Okay, now, so please note a special note. The linear equation must be written in the slope-intercept form. So for example, if we are given an equation such as 3x plus y equals 2, in order for you to correctly identify the slope, it has to be, like I said earlier, in the slope-intercept form, which is our y equals mx plus b. If it is not written in the slope-intercept form, you have to and you must rearrange or transpose the equation so it looks like y equals mx plus b. And I'll show you how to do that in a second. But for example, given the same equation, 3x plus y equals 2, and as stated earlier, we said that the slope is the coefficient on x. In this case, my coefficient on x is 3. But 3 is not my slope. The slope is only the coefficient on x when it is in the slope-intercept form. So you have to rearrange to the slope-intercept form before you can identify the slope. So now let's rearrange this equation. So rearranging this equation into the slope-intercept form, so I want this 3x plus y equals 2 to look like y equals mx plus b. I need this y to be on the left-hand side of the equation by itself. Sometimes it's called making it the subject of the equation, if you will. So everything that's not y on this left-hand side, I need to put on the right side. So this 3x needs to be moved over to the right side. And if you remember your rules of algebra, when you take something over the equation sign, the inverse happens. So this is positive 3x, so when it comes over to the right side, it'll be negative 3x. And so we can just rearrange it like how we did the other example to negative 3 plus 2. And so now it looks like y equals mx plus b. And now I can see that my slope is negative 3. Any questions? Was that clear enough? But if it wasn't clear enough, we do have more examples that we'll be practicing to help you understand. So once again, if your equation is not in the slope-intercept form, you cannot identify the slope. Okay, let's move on. Let's look at some examples, and you can write these down. So let's find the slope of y equals 3x, take away 1. Looking at this equation, and you can type yes or no inside the chat box, is this equation in the slope-intercept form? You can type yes or no. Excellent. Yes, it is in the slope-intercept form. And so right away, we can go and identify our slope. And so for this particular example, our slope will be the coefficient on x. And so therefore, my identified by the letter m is equal to positive 3. And that is it for this example. Give you a few seconds to write it down. And so if you notice, I once again have the slope-intercept form in the corner. I would suggest that you write it down every time, the actual formula, and it helps you to identify easier for those who aren't able to recognize it right away. I find that writing it every time, just like how I asked you to write the formula for the 2-point formula every time, it's better to write it so that you remember it. Okay, let's look at another example. Let's find the slope of 2y equals negative 12x plus 30. Is this example in the slope-intercept form? Okay, so I'm seeing mostly correct answers, and then I'm seeing some for those who are not quite sure. No, this isn't quite, it looks like the slope-intercept form, but we have an issue there. This 2 on my y is an issue. I need to carry this 2 over to the right side. So no, this is not in the slope-intercept form. it's not quite in the slope intercept form. So what I need to do is take this 2 and carry it to the right side of my equation. I need to make y and only y the subject of this equation. So because this is 2y, this means 2 times y. And so when this 2 comes over to the right side, the inverse operation will happen. And so the opposite or inverse of multiplication is division. So when this 2 comes over, it's going to be division. So it's going to be y equals negative 12x plus 30, all divided by 2. And so some people may be able to identify the slope right away, but like I said, I like to break it down some more to make it look more like this and sort of kind of get rid of the fraction. So if we simplify, and if you remember from the last example, because all of the numerator is divided by 2, that means each part of the numerator must be divided by 2. So negative 12 divided by 2 is going to give me negative 6, and 30 divided by 2 is going to give me 15. And so now we have something that looks like our slope-intercept form that's more simpler and not so complex. Because I know sometimes you guys get scared when you'll see fractions for some reason. I do not know why, but we'll leave that for another day. So now we can identify our slope right away, which is negative 6. And so m is going to be equal to negative 6. Any questions about this particular example? Okay, I think I have one more example here. Okay, yes, we do. Now let's look at another example. We have 3x plus 2y take away 4 equals 0. Is this in the slope-intercept form? Excellent. No, it is not. So now this one is a little more complex, but the steps are still the same. I need to make y right here the subject. So everything on this left side that is not y, I need to take over to the right side. And so I'm basically solving for y to make it look more like our equation. So first, I'm going to move this 3x, and I'm going to carry it to the right side. Because it's positive 3x, when it comes over to the right side, it's going to be negative 3x. Next, I need to move this negative 4. So now I'm going to have 2y equals negative 3x. And if you notice, I got rid of the 0 because we know 0 has no value. So I can just drop the 0 or get rid of the 0. And not really getting rid of it because 0 take away 3x is still going to give me negative 3x. And so when negative 4 comes over the equal sign, I'll have positive 4. And now we needed to get rid of the 2. And so because this is 2 times y, when the 2 goes over the equal sign, it becomes division. And so all of this is going to be divided by 2. And so we can separate the numerator and divide all parts of the numerator by 2. So I'm going to have negative 3 divided by 2x plus 4 divided by 2 is going to give me 2. And so now I have something in the form y equals mx plus b, and I can identify my slope, which is going to be m equals negative 3 divided by 2. Any questions? Okay, awesome. So now, what do we do when our equation looks like this? Y equals 2. Now, if you were here for the the lessons from the first week, when we graphed lines that were parallel to the x-axis and y-axis, some of you may remember how the graph of y equals 2 looks. But in this case, I'm going to show you how the graph looks at the end. But in this case, when we have y equals 2 and we want to find the slope, we basically are still going to make this y equals 2 look like y equals mx plus b. And so let me show you how we're going to do it. So now, because you don't see no x there, what we can do for this particular example is we can put x there. But in order for us to put x there, the number in front of x needs to be 0. Because we didn't have no x, we can use our 0 to represent our coefficient on x. And because we know 0 times anything is still going to give me 0, that makes this statement right here true. So if I had to simplify this particular line would eliminate the x, because 0 times x is going to give me 0. And when you simplify, 0 plus 2 is still going to be 2. So does this line y equals 0x plus 2 make sense? Send a yes. Okay, excellent. So I'm seeing a lot of people saying yes. I saw 1 or 2 no's. So one more time, I need to make this equation look something like y equals mx plus b. But because my equation didn't have any x, I can just put 0x, because then if you have to simplify, 0 times anything is going to still be 0, and that basically eliminates whatever was here. But for the sake of this equation, I'm trying to identify my slope. And so I need to, because I put something there that wasn't there, as long as you multiply it by 0, it's still correct, because the 0 is then going to eliminate it if you simplify. So now we have something that is in the slope-intercept form, and I can identify my slope. And so my slope is going to be 0, because the coefficient on x is 0. And here is where I'm going to show you why this statement is true. Let's look at the graph of y equals 2. If you remember when we were plotting the lines for y equals a number and x equals a number, this is how the graph of y equals 2 look. My horizontal dark line is my x-axis, and my vertical dark line is my y-axis. And so we know that this point right here is 2. Therefore, this horizontal line represents the equation of y equals 2. And if you remember from the lesson when we were talking about positive, negative, undefined, and 0 slopes, any horizontal line will have a slope of 0 because there are no tilts and no inclinations in this particular line. It's a flat line, so we have this line has absolutely no steepness, therefore the slope is 0. So this particular graph right here is the proof that our y equals 2, or y equals any number, our slope will always be 0, because the graph will have a horizontal line as such, and it has no steepness, no tilt, therefore the slope is 0. So did this graph, if remembering how this graph looked, did this help you understand more why our slope is 0? You can send yes or no in the thumbs up in the chat. Better. Okay, let's look at another example, our final example. So now, what do you think will be the slope of x equals 2? I'm going to give you a second. Let somebody can take a wild guess. What would be the slope of this? Remember to keep in mind of how the graph looks for x equals 2. So you can send your, I see a correct answer. Oh, 2 correct answers. And then I see some people actually doing the steps like what we did in the last example. So let's look at how it will look. So now I need to make this x equals 2 looks like y equals mx plus b. So because we didn't have any y, I can put a y there and put 0 as the coefficient on y. Because remember, the 0 times y will eliminate y. We'll end up with 0 on the whole. And then I can take my x, put it on the right side, where it will become negative, and the 2 will remain. So now I have an equation that looks like our y equals mx plus b. But now, remember, this is still not quite in this form. I need to get rid of the 0. And so the 0 will come to the right side and divide both negative x and the 2. And so I will have something like y equals negative x plus 2, all divided by 0. And if you remember from our last lesson, anything divided by 0 is going to be undefined. Therefore, my m, or my slope, is going to be undefined. So those of you that said undefined, you are correct. And so let's look at the graph as extra validation why this is undefined. So the graph of x equals 2 looks like this. It's going to be a vertical line that cuts the x-axis at the point 2. And if you remember from the orientations lesson, all vertical lines have an undefined slope. So, but okay, great. So I'm seeing most persons say yes. Okay, excellent. So for those of you that didn't quite understand, here is a link. We don't have time to watch the video, but here is a link that I'm going to copy and paste inside the chat box for you to watch during your own time. 1 second. Oh. So this link will take you to a YouTube video that you can watch during your own time. Oh, wait 1 second. I don't think you can see that. Okay, you should be able to see it now. This link will take you to a YouTube video that basically recaps most of the examples that we did, and you can pause it and do whatever in your own time. Also, there's another 2 additional links. Okay, so for those of you who would like additional practice, there is a link to a game that you can practice. And then the final link is basically all of the information for those of you who aren't as visual and won't quite understand the video. Here's a link with words for those of you who like to read. And then I'm also going to provide my email address. If you have questions along the way, you can just send me an email and I will answer you back as best as I can. Okay, so all of the information that you need is provided inside. If you have any additional or any final questions, you can ask now. But if not, that basically sums up our entire lesson for today. And as stated earlier, this is our final lesson on graphs. Tomorrow we will be moving on to some more algebra, I think specifically laws of indices. So be sure to be there for lesson 1 from the beginning.
Good morning, grade 6, and welcome back to another exciting week in reading comprehension. Today, we're going to be going over literary devices on today in our lesson. My name is Miss J. Stuggs, and I will be your facilitator for today's lesson. Let's go ahead and see what our objectives are for today. By the end of this lesson, students will be able to identify forms of figurative language such as metaphors, idioms, hyperboles, and similes. 2. To explain the literal meaning and figurative use of words. And 3. To interpret and express sensory impressions, that is, your thoughts and feelings gained from a given selection. So let's go to our next slide. Have you ever heard these statements before? My backpack is so heavy, it weighs a ton. Or have you heard, it's raining cats and dogs outside? Really? What about, he played it as cool as a cucumber? And lastly, he's the black sheep in the family. Well, if you have, know that they are all examples of figurative languages. Using figurative language creates images for anyone reading or listening to it. The writer may use comparisons, exaggerations, or repetitions to make his or her writing more interesting for the reader to read. These images help you to see exactly or visualize exactly what the author is writing about. So the 4 types of figurative languages we're going to focus on today are similes, metaphors, idioms, and hyperbole. Let's go and figure out what a simile is. A simile compares two unlike things using the words like or as. For an example, the fog was as thick as a blanket around us. Which 2 things are being compared here? If you said fog and blanket, you are absolutely correct. The fog is being compared to the thickness of a blanket. Let's go to metaphors. A metaphor is a figure of speech that directly compares one thing with another. And notice metaphors do not use the terms like or as. So let's look at our example sentence. The sun was a glowing orange ball of fire. Which thing is being compared directly with another? If you said sun, an orange ball of fire, you are absolutely correct. The sun is being compared to a glowing orange ball of fire. So let's have a face-off with similes and metaphors to see how they are alike and how they are different. There's a picture on the screen. It's an oven in a room. What simile do you think they came up with for this picture? The room is as hot as an oven. What do you think the metaphor is going to be? The room is an oven. Notice the difference. The room is as hot as an oven, and the room is an oven. See the difference with the simile and the metaphor? So in this case, we see that the room and the oven is being compared in the simile example, and then with the metaphor, directly comparing the room as an oven means that it's extremely hot. Idioms. Let's find out what are idioms. An idiom is a phrase that says one thing but actually means something quite different. For example, go out on stage and break a leg, boy. Now, do you think the author really means to go and break a leg as you see in the picture there? No. This statement doesn't literally mean to go break a leg, but the writer is saying to go out on stage and do your best, please the crowd. And lastly, let's go over hyperboles. A hyperbole is an exaggerated statement with humor used for effect. It helps readers to understand the extent of the emotions, attitudes, or feelings used. So let's look at our example sentence. Oh man, my feet are killing me right now. Alright? The author's not meaning that the feet are actually killing them or literally killing him. But what the author's trying to overemphasize is the pain that is coming from his or her feet. Everybody understands that? So, let's go over our literary elements trivia. You're going to match the definition to the correct figurative language below. Number 1. An exaggerated statement with humor used for effect. Is that A, simile, B, hyperbole, C, idiom, or D, metaphor? If you said B, hyperbole, you are absolutely correct. Let's go to number 2. A figure of speech that directly compares one thing with another. If you said D, metaphor, you're on the right track. Way to go, boys and girls. Let's go to number 3. A comparison of two unlike things using like or as is, yes, A, a simile. And number 4, a phrase that says one thing but actually means something different is, there you have it, an idiom. So your answer should have read B, D, A, C. Very good, boys and girls. You're on the right track and paying close attention today. Let's go to our next slide. So, what's your catch? You're going to look at the pictures below. Come up with a figurative language for each one. The first picture is a picture of a Grinch. You're going to come up with a simile. The second picture is a picture of a spinning top. You're going to come up with a metaphor. And the last picture is the picture of a cat with a boy and he's holding his tongue, which is an idiom. You're going to come up with an idiom for that. Pause the video, give yourself a few seconds, write down your 3 figurative language statements, and then you're going to share them. Alright, and we're back. Now, you would have shared your own with someone that is sitting next to you, but I'm going to share my own with you. For the simile I came up with, Susan is as miserable as a Grinch. For the first picture. The second picture with the spinning top, the metaphor I came up with was, Johnny's life is a top spinning out of control. And lastly, the idiom, what's the matter, Dawn? Cat got your tongue? So everybody saw my 3 examples and I used those pictures to come up with a statement using figurative language. Very good, boys and girls. Now let's recap our lesson. And you can go ahead and practice more and more of these similes, hyperboles, idioms, and metaphors and use them in your writing to make your writing more interesting and creative. So first question. Why do writers use figurative language? If you said writers use figurative language to make their writing more interesting, you are on the right track. Question number 2. List 4 types of figurative language mentioned in the lesson today. I hear you, and that's correct. If you said similes, metaphors, idioms, and hyperboles, you're on the right track. Question number 3. Differentiate between a simile and a metaphor. If you said a simile compares two unlike things using like or as, and a metaphor directly compares one thing to another but does not use like or as, you're on the right track. Very good, boys and girls. Let's go to our next slide for question number 4. What then is an idiom? If you said an idiom is a phrase that says one thing but actually means something quite different, you're on the roll. And lastly, what is our last question? What is a hyperbole? If you said a hyperbole is an exaggerated statement with humor used for effect, you are absolutely correct. Great job today, boys and girls. You were paying close attention to the day's lesson. These are our resources, and I want to say to you, you've been a terrific audience today. Tune in next week for part 2 of literary elements. See you next time. Thank you and goodbye.